Hello there, everyone, and welcome to another edition of Starry Skies, the magazine programme that tells you all about what's in the night sky in this month of July. I'm Mark Hardacre.
And I'm Steve Tonkin.
And we're back again in this baking hot studio recording this. It's not live, ladies and gentlemen, it's not live. You may have noticed it, but it's hot today, isn't it?
It is. Definitely in here it is.
Oh, so let's hope it stays nice and warm for the rest of July. And, yeah, that will give us some clear skies as well, hopefully. Anyway, we're over the worst of the dark sky, or lack of dark skies, aren't we?
Yes. I mean, everybody else thinks, oh, no, the days are getting shorter. And astronomers think, oh, yes, the nights are going to start getting longer.
You get confused already. Yeah, so we've had the summer solstice now, the June solstice. And, of course, now nights are drawing in towards winter. Sorry to be a harbinger of such bad news, but
Lovely.
We really are getting shorter days and longer nights, which is good for astronomers, isn't it?
It is.
Anyway, the summer solstice actually is on Saturday, or was on Saturday, the 21st of June. And that is when the sun reaches its most northerly point, touches the Tropic of Cancer, right?
Yeah, it's overhead at the Tropic of Cancer, just for a moment, and then it starts going south again.
And then it starts going south again. So it reached that point, actually, at 03:41. But we wouldn't be able to see it then, would we? Because that was the middle of the night.
Indeed. Even at this time of year, the sun's below the horizon at 03:41.
So the sun is in the northern hemisphere still, and it will be like that until September, when it will, in fact, then cross the equator back to the south, where it will stay until next March. So that's the movement of the sun. But July's a bit of a don't worry stars, we'll be back again type of month,
it is,
isn't it?
Yeah.
Many of us take a break from stargazing this month because the nights are so short. And really, if you want to get out with your binoculars and telescopes, you're really limited to at most an hour, aren't you, around... And it's 1 o'clock, not midnight.
It's 1 o'clock because it's actually summertime. So the clocks have gone an hour forward. But real time, midnight is 1 o'clock summertime.
Yeah, so it's a pity, really, because the July skies really do have some delights in store if you can stay up and enjoy them up to 1 o'clock or midnight. So even by 11 p.m, the sky's barely dark, and the waxing moon, of course, doesn't help.
Nope.
It will be low in the southern sky through the beginning of the month, with the full moon due on the 11th of July this month. And the days just before and just after that are even worse for astronomy, aren't they?
Yeah, because everything gets washed out. What little dark patch of sky you have sort of up to the south is now no longer there because the moonlight's washed it out.
Exactly. But by the 21st of July, which is the 56th anniversary of the first moon landing, we should be okay then, because the moon will not rise until almost 1 o'clock in the morning. So, yeah.
Well, that's good. The other thing we can do at that time of night, of course, this time of year, of course, at night, is, we mentioned it last month, look for these things called noctilucent clouds. You'll see the northern horizon, it's very light, and look up above its lightest bit, and these very, very silvery diaphanous clouds.
Yeah.
Once you've seen them, you'll never mistake them for...
Right. And just remind us again, Steve, what actually is a noctilucent cloud?
Well, it means night shining.
Okay,
noctilucent, and it's basically ice crystals.
Ah, right.
And they are
very high up.
Very high up, sort of 35 to 50 miles up, so much higher than your weather clouds, and they're lit by sun just below the horizon.
So it's like a reflection of the sun in the northern sky, low down. And it looks like cirrus clouds, is it? Is that the sort of thing?
It can look like cirrus clouds. It can look just like very, very faint patches. It depends. It's just like ordinary clouds vary a lot. Your noctilucents do as well.
Yeah.
I mean, we had a fantastic show during the first lockdown, I seem to remember.
We did,
that
indeed.
Was
I remember
gorgeous that summer.
Yeah. We also had a comet then. That was when we had Comet Neowise.
Comet Neowise, yes.
Yeah, so if any of our listeners remember seeing Comet Neowise, I think it was around this time, July, wasn't it? Of that lockdown year. And I do remember seeing those noctilucent clouds up at Knowlton. There were a lot of people on the rings at Knowlton there gazing north. So, yeah, I remember seeing those. Cool. So have a look out for them. June, July into August is the best time to see them.
Yeah.
And again, low in the north, underneath Polaris, which we'll come to in a moment or two.
Well, because that's part of our constellation of the month, is it not?
It is indeed. But first, we'll just have a quick look at the planets, because it won't take us too long, because there's not much to see this month. We're struggling to really see any planets. You remember at the beginning of the year, we were full of talking about these parade of planets.
Oh, yes, that was...
The newspapers were full of it. Well, we're struggling to see really any this month. Mercury, Jupiter, Saturn, Uranus, Neptune, no good.
No.
All either too near the sun in the sky or poorly placed for viewing right now. So about the only one you can see is Mars.
Yeah, but at least it's bright.
Yes. And in fact, this last couple of weeks, and the next couple of weeks, you'll find it in the constellation of Leo, low in the west after dark. So around 10:30, 11, as it's dropping dark, have a look to the west and you should be able to see Mars fairly close to the star Regulus in Leo the Lion. It's going to be moving around that area for the next couple of weeks. Have a look and see if you can see it.
Yeah.
Anyway, what else? If you get up early in the morning,
Yeah.
you might just be able to spot brilliant Venus.
Yes, it's bright, it's unmissable.
Yeah. And on the 20th of July, we talked about the 20th of July, that's the anniversary of the landing. If you have a look out, say 3:30 in the morning, that thin crescent moon and Venus will be fairly close together in the eastern sky. There you are. You're looking to the west to find the moon and Venus. When it gets dark, let's go back to the evening. Turn your gaze towards the southern horizon. So we're now looking south, mid-July, mid-month, and about 11:30 as it's just dropping dark. And there you will see the zodiac constellation of Scorpius. We talked about this last month.
We did.
With its brilliant red star Antares, which we talked about last month. And next to it now, which we didn't talk about last month, is Sagittarius. And that's a lovely little asterism, isn't it, there,
It
Steve?
is. It's so-called Sagittarius, so-called an archer. It's often depicted as a centaur with a bow
Yep.
and arrow. But actually, it looks like a teapot.
Yep. And it's really quite obvious. It's quite large. I always thought it was a smallish teapot, but it's really quite large. Maybe because it's low down to the southern horizon, so you've got something to show a scale. But there is definitely a spout.
Indeed.
There's definitely a handle. And what comes out the spout, Steve?
Oh, well, steam or the Milky Way, if you prefer.
Yeah.
They've got the Milky Way, our galaxy, just rising up out of there. It's... Yeah.
And we'll put a picture of that on the Forest FM Facebook fan page, because at this time of the year the Milky Way is at its best. You don't get very many hours of looking at it, but the Milky Way between Scorpius and Sagittarius is the brightest in the sky. It's low in the south, but see if you can find that.
So
And again,
why is it so bright there then, Mark?
because we're actually looking towards the centre of our galaxy. Of course, that's what the Milky Way is, isn't it? It is our galaxy.
Well, it comes from the galactos, is Greek for milk. So,
Well, there you go. And I did know that. I think I did.
Yeah,
I did
I'm
know
sure
that,
you did.
Yeah. But the Milky Way actually stretches all around the sky. We are in the middle of this thing, and we can look in the direction of the Milky Way all around us, but it's at its brightest in that area, that patch we just talked about, apparently coming out of the spout of Sagittarius. Okay, anyway, let's turn so we're looking south. Let's turn 180 degrees, and now we're looking north. So we're looking towards where the sun will be. It's below the horizon, roughly north around midnight. And there you'll see our constellation of the month, which for July is Ursa Minor, which is the little bear. Not particularly prominent, Steve.
no, but once you've found the main star in it, which is Polaris, which you get to, if you remember, by following the two pointer stars at the end of the Big Dipper.
Yeah.
And you follow those up, and it's a handspan away. If you hold your hand out in front of you, stretch your thumb to your little finger, and it's a handspan away from there, and it's this not particularly bright star. Lots of people think, oh, pole star must be bright. It isn't particularly bright, but it's bright enough to be seen in these brighter summer skies.
Yeah.
And that is always going to be above the north point on the horizon, which is why it is so important for navigation.
Indeed.
And has been used for this for thousands of years.
How do we find the Plough, though, right now? Is it so? If I'm looking roughly, if I've got my compass or my iPhone and I pointed it north, whereabouts is the Plough then? Where would I find that in July?
I think it's slightly over to the left of the pole. Is that
That's
not?
it. Yeah, so it's
And high.
sliding down, isn't it? Towards it's sort of halfway down the sky.
Yeah.
You know, the Plough rotates around the pole star once every day, and we see it in July just a little bit off to the left. So a little bit left of north, which is a little bit west of north.
Yes. And you'll find it gets lower and lower and lower in the evening sky, but we'll talk about that later in the year, because there's some interesting mythology around that.
Yeah, there is. And so we're now looking at, we found Polaris, okay? And that's the brightest star in Ursa Minor. So astronomers call that Alpha Ursa Minoris. What's that all about?
Well, Alpha is usually the brightest star of the constellation. Isn't always.
Right. Is that anything to do? That's the Greek alphabet?
It is the Greek alphabet, yes.
Right.
So you use the Greek alphabet, and then we also have numbers. It's star naming systems. There's so many of them, and they're catalogue numbers. But Polaris, Alpha Ursae Minoris, which means the brightest star, the alpha star of the lesser bear.
So presumably, and then the next brightest star would be called Beta. Am I right?
Indeed.
Followed by Gamma, Delta, and so on.
Yeah. And we'll talk about Beta and Gamma later, because they're interesting little stars in their own right.
Yeah. So it's good if you're an astronomer or a budding astronomer to learn the Greek alphabet, isn't it?
Yes. And how many people here know how to do a zeta?
Zeta.
Or an xi?
Very tricky.
Yeah, but it's worthwhile.
Yeah.
But
anyway.
look at Polaris
Right.
in binoculars. Okay, you need to something like 8 times, 10 times magnification, so 8 by 40s or something like that. And you'll see it's the bright star in a slightly wonky ring of stars. It's a very slightly wonky ring, and it's looks just like a sort of slightly bent engagement ring with a solitaire diamond. And it's pretty. And I love these little binocular asterisms, we call them, these little informal patterns of stars. And they help you remind things. And I look at that. Every time I look at it still, and I've been doing this for decades, I smile.
Yeah. And it's true. Steve does a column in Sky at Night magazine, for those interested. Sky at Night magazine is on your bookshelves in all the leading bookstores. And he does a binocular tour every month in that fantastic magazine. Go and buy a copy. And he puts in all sorts of interesting little asterisms like this. Just little collections of stars that catch your eye and make you smile. And as I say, as you said, Steve, that engagement ring by Polaris is super, isn't it?
Yeah.
It's really nice. We've put, by the way, a map of the whole constellation on the fan page, so you'll see the shape of Ursa Minor. It's not a big, bright constellation like Orion or the Plough, but once you've found Polaris, you'll find the rest of the constellation.
Yeah.
And, it's a nice little constellation of the month to have. Okay, so the reason the pole star is good for navigation is it sits above the North Pole of the Earth, right?
Yeah, that's right.
So as we rotate... So am I right then in thinking, Steve, if I was at the North Pole right now and looking up, would I see the pole star right above me?
Yes. Well, no, because it's not dark enough at the North Pole yet, but in principle, yes. The pole star would be right above you.
What happens if I'm at the South Pole? Is there a South Pole star?
Well, there is one near. It's one called Sigma Octantis. It's not very bright, and unless you know your way around the southern sky, it's not that easy to find either.
Right.
But
so we're just lucky, are we, here in the Northern Hemisphere, that Polaris happens to be above the North Pole? Is that right?
At the moment.
At the moment. Oh, so it's not always been like that?
No, because when you get a spinning top, and you spin it, the axis of rotation sort of wobbles.
Oh, yes.
That's called precession, and Earth's axis of rotation does exactly the same thing. So about 5,000-6,000 years ago, the pole star was a star called Thuban. which is in the constellation of Draco. So for the ancient Egyptians, when they built their pyramids, Thuban was their pole star. And give us about 12,000 years, because this wobble takes nearly 26,000 years. The star Vega, which we will be talking about, no doubt, sometime, part of the Summer Triangle.
Yeah.
Vega will be the pole star. So
but that's thousands of years hence.
That's about 12,000 years.
12,000 years
yeah,
from now.
So we won't be around for that.
Yeah. Actually, the pole is getting the actual pole is getting closer and closer to the pole star, to Polaris right now. And I think the next couple of years it's the closest it will ever be, right? Yeah. I think so.
It could well be.
Yeah. Anyway, the great thing about it, of course, is that wherever you are on the planet, if you can see the pole star, you know where north is, which was great for navigators, as you said, for centuries, wasn't it, really? But it's actually an interesting star in itself. I think it's underplayed. We don't talk. We think so much about it being the North Star, but it's really quite an interesting star.
So why is that?
It's both a variable star and a multiple star, a triple star. So with the naked eye, you just see one star, right?
Indeed.
But with a small telescope, how about with your binoculars? Can you see?
I've never noticed it as a double or a triple.
So you need a small telescope for this. You can see that it's got a fainter companion called Polaris B. So the big star is Polaris A, and there's a fainter companion star called Polaris B. Now you need a telescope for that, and probably something like a 3-inch telescope, a not insignificant telescope. But then,
and when we talk about a 3-inch telescope, we don't mean 3 inches long.
No.
We mean an aperture of 3 inches.
We should really use 75 millimeters.
Yes.
Yeah. Steve and I grew up in the age when we were all talking in inches, and the 3-inch telescope was Patrick Moore's favourite go-to startup telescope, wasn't it?
Yeah.
And it was reasonably inexpensive then, but today you can get 80 millimetre, 100 millimetre refracting telescopes, and they're all very good. So with that sort of telescope pointed at the pole star at Polaris, you'll be able to see both A, the brighter one, and then faint Polaris B, not too far away. However, if you have a telescope the size of the Hubble Space Telescope in your garage, get it out, because you need that sort of monster to find the third companion star, which is known as Polaris AB. And that is a star that orbits right next to the bright Polaris. It's tiny, it's faint, and we can barely see it. We can only see it with something like the Hubble Space Telescope. And it orbits around the main star once every 30 years. So this is a triple star system of 3 stars. Imagine sunset there. It'd be quite busy watching all those 3 stars set.
Chaotic.
It would be, yeah. But it's also a variable star.
What does that mean?
Well, yeah, its brightness varies slightly over a period of about 4 days. Now, it's not much, is it? You wouldn't notice it, Steve. If, with your binoculars looking, you wouldn't notice that change.
No, you'd never see it in binoculars.
Yeah, it's barely detectable. It is detectable, but barely with the naked eye. So you really need to have some form of photoelectric camera detector to spot this. Yeah. But it's very important to astronomers, and it's called a Cepheid variable. What's a Cepheid do?
Well, it's named after a star called Delta Cephei, or Cephei, depending on how you pronounce your Latin Cs.
Yep.
And so in Latin, the C is hard, as in iceberg.
Yep.
Sorry, incredibly poor joke. Dear. And
sorry, listeners. We're plumbing the depths here today.
And these Cepheid variables, what they do is their intrinsic brightness is related to the time, the period over which they vary. So if you could measure the period of variation, you know how bright it actually is.
Right.
And then, if you know how bright it is and you know how bright it looks, you can work out how far away it is.
So what's the mechanism for it? Why does it brighten and dim over 4 years? What's the reason for that? Is it running out of fuel, or is there someone turning a switch on it? What's doing it?
I think it's probably pulsating. And I don't understand the full mechanism of this sort of thing, so, it's not something I've really looked into. It's just sort of nice to know that these things happen. But what happened was, back in the early 20th century, an American, she was called a computer. She did the calculations. Henrietta Swan-Leavitt, her name was. She looked at these stars in one of our neighbour dwarf galaxies, the Large Magellanic Cloud, and realised that this relationship between their luminosity, their intrinsic brightness, and their period was same. And since then, they've been used to find distances to other things, other galaxies. So when Edwin Hubble, of the telescope fame, worked out how far away the Andromeda Galaxy was, he did it using these stars, knowing how bright they were, and then being able to see how bright they looked.
Yeah, so that means, doesn't it, that if the star isn't particularly bright, it pulsates quickly, bum, 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 bum. But if it's a really huge, bright Cepheid, its pulsations are slow. So you can tell how bright it is, therefore how far it is away. And that must have been a terrible surprise for Mr. Hubble to discover that the Andromeda Galaxy wasn't a few thousand light years away. But how far?
2.5 million.
2.5 million. And that's all discovered by the aid of these wonderful Cepheid variable stars.
But just think about that for a moment. 2.5 million years, our species, Homo sapiens, didn't exist.
Yeah. So the light that we see from Andromeda has been on its way to us for that length of time.
Well, since we were Australopithecus, I think.
Yeah, that's it. That was Mr. Hubble's contribution, and I think that's probably why the Space Telescope was named after him, wasn't it?
Indeed.
Because he discovered that not only is the universe much bigger than we thought, but it's also expanding, which is an interesting concept. Anyway, back to Ursa Minor. Let's just talk a bit about the constellation itself. So it's pretty ancient. It was recognised by ancient man around his campfire, probably, and one of the 48 listed by that 2nd century astronomer Ptolemy. And though it's not particularly bright, it has a rich mythological history. And to the Babylonians, it was associated with their god Damkina. I didn't know that.
I didn't know that either. What was Damkina god of, do you know?
Damkina, I don't know.
Something for the listeners to find out and tell us.
Yeah, that's good. Anyway, let's get on to that second brightest star. Look at your star map and have a look. There you find Kochab.
Beta.
Which is Beta.
And it's just about as bright as Polaris.
Yep.
But it's red. Yep. Well, reddish, orangey.
Yep. Definitely to the naked eye, it's clearly a different colour. And they're so close, they're fairly close together, Polaris and Kochab. You can actually see the colour difference. One is bright white, and the other is clearly orange. And in binoculars, even better.
Oh, yeah.
Yeah.
And if you want to get the colour even better in binoculars, defocus them very slightly. And the colours really zing then.
That's a good tip. And it's also slightly variable. So many of the stars in the sky are slightly variable. And it turns out that lots of the orange and red stars also vary. They go up and down in brightness. They swell, they puff out their atmosphere and then shrink again. So the most stable stars are the white and the slightly yellowy ones, like our sun, which is fortunate for the human species.
It is. It gives us time to evolve.
Indeed.
Yeah.
So what about, we usually talk about deep sky objects, don't we, in Constellation of the Month?
Before we do that,
let's
just go back to Kochab. The other nearly bright star just near Kochab is one called Firkat, which is quite a lot fainter.
So is that Gamma then?
That's Gamma.
Aha, right.
And Kochab and Firkat together, if you look over the period of a night or, just look at it's like they circle the pole. They guard the pole. So they've been known in ancient times as the guardians of the pole. They were the sentries that kept anything else away, like the dragon, away from the pole.
Right. So, and what colour is Gamma? Do we know? Is that a white star?
It's a whitish star,
white star. So there's a good contrast also with Kochab. You've got a white and an orange star close together there. Right. So anyway, we've talked deep sky. Usually we talk about the deep sky objects, meaning the nebulae and clusters and galaxies that you can see in the constellation of the month. But we're really struggling a bit this month, Steve. There's not too much to see.
No, there is not around there. And also because the sky's not so dark, it's difficult to see our faint fuzzy blobs, as we like to call them.
Yeah. You may just find one open cluster, which is a nice one. It's actually slightly across the border in the constellation of Cepheus or Cepheus. It's called NGC 188. It's marked on the map, so that's why I mention it, because it's on the map. It's a faint patch of stars in the telescope. That's about it. Not much to see. It's probably 100 or so faint stars, but see if you can see it. There is, though, however, a very interesting galaxy here. You won't be able to see it from home, and it wasn't even discovered until 1955. So I'm going to test Steve here, see if he's ever heard of this thing. It's called the Ursa Minor dwarf galaxy. Now, have you ever heard of it? Honest?
No, I haven't.
Yes.
Well, I have just this morning.
I got him. I finally got him. Because I didn't know either. Yeah, we do some research for this program, honestly, listeners. And the Ursa Minor dwarf galaxy is one of those faint galaxies that orbits our own Milky Way. And it's really quite large in the sky. It's much bigger than a full moon, but very, very dim. You have to take an image of it with your camera over several hours, or an hour, I would say, to be able to capture it. Made up of a collection of 100,000 stars, maybe, and it's quietly orbiting our galactic home.
Well.
Now, and it's like we've got several other dwarf satellite galaxies. I can't remember that. We've got Leo 1, Leo 2. These are faintish galaxies that are like little sisters and brothers of our Milky Way and orbit around us. But I'd never heard of this one, the Ursa Minor dwarf galaxy. So have a little Google for that. It's a bit of fun, and it'll tell you all about it. Very hard to see. Don't expect to get your binoculars or even a decent telescope out to see it. But fun.
But yes.
I caught him out. I can't believe it.
Oh, I do.
So, yeah, you'll see Ursa Minor, the constellation, on our monthly sky chart, together with other interesting pictures which we'll post. And you'll find that on our Forest FM Facebook page, as well as online at Fordingbridge Astronomers and at Wessex Astronomical Society. So, if you're interested in finding out more about astronomy, do please contact your local astronomy club.
Yeah, there's 3 very good clubs in this area.
First one is Fordingbridge Astronomers, which meets every 3rd Wednesday in the month at the Elm Tree in Hightown in Ringwood. Yeah. We welcome any astronomers, whether you're a novice, have no idea, but just interest, all the way to semi-professionals with big telescopes. Anybody. But you need no kit to come along.
Yeah, the only thing you need for astronomy is an interest, really.
That's it. And then we have Wessex.
Oh, yeah. Well, they meet in the Allendale Centre in Wimborne on the first Tuesday of the month.
And then up in Cranbourne Chase, up in Shaftesbury, we have Cranbourne Chase Astronomy Club. They meet on the 2nd Wednesday of the month at the Grosvenor Hotel in the centre of Shaftesbury. And you know what we do? These 3 clubs have come together. We're all brothers and sisters, really. We have a laugh. And we have an annual quiz, and it's a bit of an astronomy quiz.
Which Cranbourne Chase Astronomy Club actually instigated this last year.
Yes, they did, and it was great fun. They won it the first time round.
Oh, no, Wessex won it the first time.
Oh, that's it, right.
Wessex won it the first time round.
Yeah, set up by Cranbourne, won by Wessex, but the Sweet FA, Sweet Fordingbridge Astronomy team, trounced the opposition.
Well, I think trounced may be over-egging it, but yeah, we did well.
We did well, yeah. Anyway, all 3, as you can tell, we're all fun together. We all have lots of fun together. So please come and meet us. All 3 clubs welcome new members, and as we said, you don't need any expensive gear. Just one human eye, 2 is better, and a thirst for knowledge. So come along. The skies aren't going to be great until into August, but still, midnight, have a look out, see what you can see. Thanks for listening today. We'll see you again next month. So it's goodbye from me.
And from me. And clear skies.
All the best. Cheers.